Hi class, I'm going to bring the attendance list, but it's okay later when you start to do your exercise, I'll go back to my office to get the attendance list. So do remind me if I didn't go back to take my attendance. Okay. So today we will continue this differentiation, the basic rules of differentiation for this parametric function. Okay, now you see you have x, y in terms of x, y in terms of x. But your x and y are both in t. Okay, x and y are both function in t. So when we want to find for dy dx, okay, for example, this one, x in terms of t, y in terms of t, and we want to find for dy dx. So this is actually, this is the formula. But how to get this formula? This comes from chain rule. Okay. See your dy dx. Okay, but your y in terms of x. Okay, y is in terms of x. X is also in terms of y in terms of t, x also in terms of t. So we can get the dy dt. This one we can get the x dt. Okay, that means the extra variable is t. So to get dy dx, okay, dy dx, right? So we can have t here. Okay, we can have extra t here. But after you cancel out the dt, we still have dy dx. We didn't change anything. We just made use of the chain rule to come up with this formula. Okay, and this is actually dy dt over dx dt. This is multiplication. This multiplication, it means dy dt divided by dx dt, right? When you change this into this, you have to upside down here. Okay, so this is actually equals to this, and this means dy dt divided by dx dt. That's why we have this formula, okay? Dy dx equals to this. We have this formula for the parametric function. These four parametric functions, okay, x and y are both in t. Okay, not necessary to be t. It can be data. It can be any other same variable. Okay, so if you look at this example, okay, dy dx. So we want to find for dy dt first. Okay, dy dt is 4t. Okay, 4t. Yeah. Divided by this one dx dt. So dx dt is 4e4t. Okay, then we get the result, and this answer will be in terms of t, because both x and y are in terms of t. So the dy dx will be in terms of t. Okay, just follow the formula. Okay, dy dt over dx. Okay, so this is for parametric function. Okay, the parametric function. Okay, and there's another type of differentiation. We call it as implicit differentiation. Okay, implicit differentiation is used whenever your function cannot be expressed in this form. Okay, normally when you have y in terms of x, we can directly compute for dy dx, right? We have y in terms of x. But if you have an equation where we can't get to express y in terms of x, for example, this one. Okay, if you want to express y in terms of x, it will be y equals to plus minus square root of 3x. You have two functions now. If you want to express y in terms of x, and then when we want to do the dy dx, okay, it will be troublesome. Okay, and another example, for example, this one. Okay, we don't express y in terms of x because of this y squared. Okay, another example, this one. This one, we can't we can't get to express y in terms of x. Okay, so for this kind of functions, okay, or equations, when we want to find for dy dx, we have to use this implicit differentiation. Okay, so you see all this kind of function, this one. When you want to find dy dx, we can't express y in terms of x. Okay, there's no way for us to express y in terms of x. So that's why implicit differentiation, okay, need to be used. Okay, now we will look at how to use the implicit differentiation. Okay, for example, this one. When we want to find for dy dx, we have to differentiate every single terms with respect to x. Okay, with respect to x. Okay, this one, right on the board. Okay, y squared equals to 3x. So when we want to differentiate both sides with respect to x, it means we have to differentiate this y squared with respect to x. Okay, differentiate this term with respect to x. And also, when we differentiate this one with respect to x, we get 3. Right? There's no issue because this is in x. When we want to differentiate this with respect to x, we get 3. But this one, we want to differentiate with respect to x, we can't proceed directly because this is y, this is not x. So from here, this one, the d over d over dx. Okay, we use chain rule, d over dx, this one, d over dx, and we insert. Okay, we insert a new one, which is dy dx, because we want to differentiate. This is y. This is in y. So we want to differentiate this one in terms of y. So when you insert this dy, that's when you have a dy here. This is chain rule where we can cancel out this one. When you cancel out, you still have d over dx y squared. We didn't change anything. Okay, so this one, when you differentiate y squared with respect to y, what do you get? You differentiate this one with respect to y. You get 2y, right? You get 2y. Okay, for this part, you get 2y. And you have a dy dx here. Okay, so when you differentiate y squared with respect to x, you get this one. And on the right hand side, you get 3. Okay, you get 3. So what we want dy dx. So that's mean your dy dx will be 3 over 2y. Okay, this is how we find for the dy dx by using implicit differentiation. Okay, I give you one more example. Let's say we want to differentiate with respect to x or the function of, let's say, sine y. Okay, we want to differentiate this one. This is in y, not in x. So when we want to differentiate this, we have to do this. We have to insert a dy because this is in y. Okay, after you insert dy here, now we differentiate this one. We get a cos y and then dy dx. This means cos y times dy dx. Okay, so in short, when we want to differentiate a function in y with respect to x, you differentiate the function y with respect to y, but followed by a dy dx term. Okay, so if you have, let's say you want to differentiate e to y, you want to differentiate this function. Okay, so what do you get? Y. When you differentiate exponential function Yeah. Okay, we go directly to this one. So when you differentiate this one with respect to y, you get 2e2y, and then d by dx, followed by a term d by dx. Okay, you don't have to write this. You don't have to write this out. Okay, because this is for your reference. Okay, you understand this one, then you know how to get this. So we just go straight to get the answer. Okay, so another example, let's say you want to differentiate x plus y. X plus y. So we differentiate this one, we get 1, right? Differentiate this one with respect to x, we get 1. And plus, you differentiate y with respect to x, you get 1 times dy dx, right? Differentiate y with respect to y, you get 1. But because of this is y not x, you have to insert one more term dy dx. That's why you get the dy dx here. You need to be familiar with all this. Okay, one more example. Let's say ln to y. Ln to y. We will differentiate this one with respect to y. Okay, with respect to y. So what do you get? 2y, it will be here. Differentiate this one with respect to y, you get a 2 here, right? And then dy dx, because this is y, not x. So whenever you differentiate a y function, okay, the y term with respect to x, you differentiate that function with respect to y first, followed by an extra term of dy dx. Okay, so this is the first step for you to understand the implicit differentiation. Okay. Okay. Now we go to the next example. Okay, this one, x squared plus y squared. X squared plus y squared equals to 5x. Okay, so differentiate all these 3 terms with respect to x. So this one, 2x, because this is in x, so no issue. Plus 2y dy dx. Do not forget about the extra term dy dx. Okay, dy dx. Because this is y. Whenever you differentiate a y function with respect to x, you differentiate as usual with respect to y, but followed by an extra term of dy dx. Equals to 5. Okay, we want to find for dy dx. So we want this term to stay on the left. 2y dy dx equals to this one moved to the right. Then we can get the dy dx. Okay. We don't have to express y in terms of x. By using the implicit differentiation, we can get a dy dx. And the dy dx will be in terms of xy, no issue. Okay. Any questions? Okay. The first 2 are simple example. Okay. Next one. We look at the example that involves the product rule and also the quotient rule. Okay, this is xy. Xy equals to sine xy. Okay. Now we look at the left-hand side function first. We want to differentiate. Okay, differentiate xy with respect to x. Okay, we settle this one first. So this is uv. This is u times v. We use product rule. Product rule, that means copy, and then we differentiate. Differentiate y with respect to x, you get dy dx. Plus, now copy the y, differentiate x with respect to x. 1. Okay, so you get an x dy dx plus y for this term. Okay, next, we look at the right-hand side function. Okay, before this, okay, I want to remind, okay, how to differentiate this sine function. Okay, let's say you have sine 2x. What do you get? You get a 2 cos 2x. You get a 2 cos 2x. Because differentiate sine, you get a cos function with the same angle, and then you differentiate this one with respect to x, you get a 2 here. Same goes to this one. Okay, then say differentiate. Now we want to differentiate sine xy with respect to x. So differentiate sine, we get a cos function. Cos with the same angle xy, and then we have to differentiate this one, multiply here. Okay, either here or here, doesn't matter because it is multiplication. So when you differentiate xy, what do you get? uv, right? When you differentiate this one, uv, that's mean this one. Okay, now you need to differentiate this one with respect to x and you put it here. So let's say this one. Okay, copy, differentiate this one with respect to x, you get it by dx, plus copy, differentiate x, you get 1. Okay, so the answer will be x dy dx plus y. Oh, okay, this is cos xy. Okay, so left-hand side we have this. Right-hand side, we have this. Okay, when you differentiate left-hand side, you get this one. When you differentiate right-hand side function, you get this one. Okay, now we make it into one line. So x dy dx plus y. Okay, this one, when you differentiate xy, you get this. Equals to differentiate xy, you get this one. X dy dx plus y, and then cos xy. Now we want dy dx. We want dy dx. There's a term here. There's a term here. That means we have to expand. We have to expand because we want the dy dx term. Okay, continue here. So that's mean x dy dx plus y equals to, okay, this one, x cos xy dy dx plus y times y. Okay, so the term that contains dy dx, we group it on the left. Okay, we group it on the left. So this one, it moves to the left. This one, we move it to the right. So this one, when you move to the left, and we can factorize the dy dx. So you have x plus x cos xy dy dx. Move this to the left, combine with this, then you factorize the dy dx. So you have x minus x cos xy. Okay, minus 3 minus equals to this term y cos xy minus y. Okay, then we can get the dy dx. So your dy dx will be y cos x y minus y over this x minus x cos x y. Okay, and we can further simplify. By factorizing y and x. Okay, you see this one, cos xy minus 1. This is 1 minus cos xy. Okay, so meaning that these two will be the same when you factorize -1 from here. Either you factorize -1 from here or from here, then they will be the same. Okay, let's say we factorize a -1 from here. So negative y over x. Okay, when you factorize negative, that means this will be negative, this will be positive. Right? Negative, positive, that's it. Positive 1 minus cos. Okay, then it will be the same when you cancel out these two. So you get a negative y over x. Okay. Any questions? At this stage, I want you to understand every single step. Later on, when you start exercise, if you know whether you have any questions, if you have any problem. Clear? Okay, no questions? Okay. Now then we proceed to the next example. Okay. So we differentiate. Okay, I'm making everything in one line. We differentiate directly. Okay, x, y. So this one we have to use product rule. Okay, product rule. So copy, differentiate, plus copy, differentiate x, we get 1. Okay, equals to the right hand side. When you differentiate exponential function, you will get the exponential function back, right? The same exponential function. And then we differentiate this with respect to x. Okay, with respect to x, then we put it here. So what do you get when you differentiate this one with respect to x? Huh? 1 plus 3 dy dx. Then we want the term of dy dx, so we expand. Okay, we expand. Ex plus 3y plus 3 plus 3y dy dx. Then the term with dy dx, we prove it. Okay, we move this to the left and we factorize the dy dx. So we have x minus 3e. Then exponential function minus y. Then finally, we can get the dy dx over this x minus 3e. This is your dy dx. Okay, any questions? No questions. Okay, one more example. Okay. Factorization. Factorize. Lazy to do one more line, okay? So this one move to this and then we factorize the dividends. And next one is sine x plus y. And 2x plus y. X y minus e x plus y. Okay, so we solve this in one line. Now differentiate sine function. We get a plot with the same angle, and then we differentiate the function of the angle, and we put it here. So when you differentiate this one with respect to x, you get 2 plus 1 d by dx. 2 plus 1 d by dx, that's d by dx. Okay. And then equals to, okay, this one. Copy, differentiate y with respect to x, dy dx plus copy y, differentiate x, you get 1. Okay, minus differentiation of exponential function. We get the exponential function, and then we differentiate this one with respect to x. We get 1 plus 3 dy dx. Whenever there's a y, you did the term dy dx. Okay, so this one we have to expand because there is a term of dy dx here and here. Okay, so we expand 2 cos 2x plus y plus cos 2x plus y dy dx equals to x dy dx plus y minus e x plus 3y minus 3 e x plus 3y dy dx. Okay. Then we have a dy dx here, here, and here. Okay, so these two move to the left, this one moves to the right. Okay, so this one we have cos 2x plus y d by dx, but we factorize the d by dx. This one moves This one moves dy dx. That means after you move these two to the left, and then we factorize all the dy dx. Then this term moves to the right. So you have y minus e minus 2 cos 2x plus 1. Okay, then we can get a dy dx. That means this one y minus e minus 2 cos divided by all this. Cos 2x plus y minus x plus 3e x plus 3y. Okay, any questions? We apply the product rule and quotient rule when needed. Okay, as normal. But whenever you are differentiating a function f, a function in y with respect to x, you just differentiate as usual, but you insert the dy dx at the time. Okay. Any questions? No. Okay, if no, try this exercise. Okay, for question number 1, A and B, you use the parametric differentiation. Okay, parametric differentiation because both x and y are in terms of t. And then C, D, E, F use the implicit differentiation. Okay, this is implicit differentiation. Okay. Well, 1A, y is 3 x times sine. And dy dx, the formula is dy dt over dx dt. Okay, first I go ahead and bring our attachments. You get the correct answer as in the slide. Now, dy dt. dy dt, so 1/3, and then t, 1/3 minus 1, negative 2/3. Okay, dx dt. Hypersine, you get a hypercos. T. Okay. 1/3 is here. This negative means the t should be here. And then hypercos. Okay. This negative, it means the t to the power of 2/3 should be here. And for the b, you have to apply product rule. Any questions? Okay, this is A over B. A divided by B. Need to apply product rule. Okay, this is your y. Y, and we want to find dy dt. Okay, dy dt. So, copy, differentiate, plus copy, differentiate. Product rule. Then dx dt. This is a non-function. Okay, non-function. So 2t is here. Then differentiate this one respect to t. have a 2 here. Okay, so you can cancel out the 2s with this 2. Okay, here you can simplify. You get an e negative t 1 minus t over, okay, over 1 over t, right? So this e, it can go out. Okay, when your denominator, okay, when your denominator is a fraction, so this, it can go out, okay? This happens only when your denominator is in the form of fraction function. If you have A or B over C, this does not happen because this is your denominator. This is your numerator. When your denominator is not a fraction function, okay, this one, you will just go to this. That means 1 over 2 divided by 3. That means 1 over 6. Okay, so this is A over BC. Okay, this one will join this. But if your denominator is a fraction function, then this one, the denominator of the denominator, it will go out. Okay, it all depends. It all depends on the denominator. If your denominator is a fraction function, this one goes up. But if it is not a fraction function, this one, it goes up only to this. Okay. But this one, when it goes up, it will go. Okay, I give one more. A over B over C over B. Okay, this denominator is a fraction function, so D, it goes up. Okay, this D goes up. This is AB over, this one will go to this BC. This is the same as, this one is the same as A over B divided by C over D. It means A over B times D over C. That's why you get this. So you can't get to see this, you can just write in this form. A per B over C, this means A divided by B per C. And this means A times upside down C per B. That means AC per B. Okay. And the other one, A per B over C. This is A per B divided by C. Divided by C, that means A per B times 1 over C. That's why you get A over BC.
C boleh start tinggal bawah.
This one. So C goes to A. That means T goes to this. So that means when this goes up, that means T blah 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 divided by 1. Okay, any more questions? Okay. Okay, there is one more questions which is often being asked by students when we have to use radian and degree. When we have to use the radian and degree. When you have a trigo function, okay, when you have a trigo function and you look at the angle, okay, if the angle is in, this is degree, right? Yeah. So you have to use degree. If without the degree sign, this is in radian. Yeah. So you have to use radian. Okay, this is when you have to use degree and radian. When the theta, you didn't see the degree sign, this means radian. And other than this trigonometric function, actually it doesn't matter whether you use degree or radian. Other than this, okay, that's means when you want to count for E squared, no matter you use degree or radian, it doesn't affect. You will get the same answer. Okay, you will only get different answer for the trigonometric function. And when to use, it depends on your data. Your data in degree, you use degree. Your data without the degree, that's made in radian. Very simple. Because until second year, there are still students asking the same question when we have to use degree and radian. Okay, actually very simple. When you have trigonometry, then you have to look at the data. Other than that, degree or radian, it doesn't matter. It won't affect. Okay, now C, have you done C? Okay, 3y squared, this is y. So we differentiate 3y squared, we get a 6y dy dx. Okay, then plus, okay, 4y, we get a 4. But because of the y, we have dy dx. Okay, this is x. This one plus sine x equals to 0. Then we factorize this dy dx. You get a 6y plus 4 dy dx equals to, these two moves to the right. Then you get your dy dx over 6y plus 4. Okay, this one we have to use product rule. Product rule. Okay, B. Product rule, copy, differentiate, plus copy, differentiate x, you get 1. Plus, differentiate this one, you get a 3. Okay, now UB. So let's say copy this, and I differentiate this one, I get cos y, dy x, and then plus, now copy this one, differentiate this. Copy, differentiate this one, respect to x, you get negative 1.
Oh yeah.
Right?
Betul.
We need to expand. 2 cos y dx minus x cos y dx minus sine y. Okay, then move all the terms with dy dx to the left. Factorize the dy dx. We see the information about the MTC, right? Do you get the message regarding to the MTC? The preparation for the top, right? And my slot I put on this Thursday afternoon, but actually this Thursday we do not have class. Okay, because I will be away for the part-time program. So we have no class on this Thursday. And actually the preparation for midterm I have already done with you during the week of Diwali. Okay, so I do not do any revision on this Thursday as emphasized. Okay, so just refer to the recording video that I did with you for the revision class. Okay, and there's no class. Okay, I have no class Thursday.
Cos y dx factorize. Can
Yeah, that's the book. That's all of it. Like it's all.
y dx saya
Yes, all the talks we got, yes, and post to the back. Then it factorize the difference. Actually, this one we do not have to factorize, okay, because there is only the divider is here, not here. Okay, actually we can proceed with this term. Okay, we can proceed with this term. Okay, it's this one. We can just use 2 minus x plus dy dx. Okay, we don't have to expand. And when you move here, okay, when you move here, this will be minus 2 minus x plus y. So actually, we do not need to expand because dy dx is here, not inside here. Okay, so you can keep it this one, and when you move, you just minus this one, okay, minus this term here. Then you get this. But if you want to if you want to expand, okay, actually, I won't say this is wrong. This is also correct. Okay, this is also correct. Okay, and then at the end, okay, if you just leave in this one, okay, it's also okay. Okay, any questions for D? Okay, then E. E, we do not need to apply product or quotient rule, just proceed. Okay, next, you get 1 minus 4y, you get minus 4, and then the dy dx. Exponential function, okay, you have to differentiate this one. So when you differentiate this, you get a 2 plus 3 dy dx, and then 0 e2x plus 3 minus 1. Okay, then expand because your dy dx is inside this bracket. Okay, expand. Okay, then we move this one. Okay, we combine the dy dx. Combine the dy dx. So 3e2x plus 3y minus 1 plus 4 dy dx equals to 1 minus 2e 2x plus 3y minus 1. Okay, then we can get the dy dx. Not to here, this one to here, that means you have a negative, later on you can factorize the negative, you will still get the same answer. Okay, this one I move this to the right. I move this to the right and I put it here. And this one I move to the left. 1 minus 2. Okay, any more questions for number for E? No? Okay, for the last one, F, we need to apply log on both sides. We apply the log on both sides because we want to use this log x power of a equals to a log x. We want to use the characteristic of log function, where the power of the function of log, we can bring it here. So this one, we apply the log on both sides, so that the negative x, we can put it here. Then we use the implicit differentiation to continue. Okay, so log y, we want to differentiate log y with respect to x. This is not x, huh? Not x. This is y. But still, we are differentiating the log function as usual. This one, you put it here. This one, you differentiate with respect to y, you get 1. And since this is a y function, y, you need the y x. Because of this one, you can't get to differentiate directly. Because of this is not constant. This is variable. Unless you know how to differentiate this one. With the power of a variable. Normally we differentiate and we have this. This is the constant. Okay, but we differentiate, we can get 3x squared. But this is not constant. Okay, this is not a constant. This is a variable. So we have no way to differentiate directly like this. That's why we need to move the negative x to the front. That's why we need to log function. We need to apply the log function. We want to make use the characteristic of log functions to break down the negative x. Okay. So on the right, when you differentiate this one with respect to x, what do you get?
Negative 1 over.
Differentiate this one with respect to x. Negative?
1 over 3 left.
Negative 3. Negative 3 is negative? Mana tak tahu. What is non-3? Non-3 is a constant, right? Non-3 is just a constant. There is no x here. We won't have over. Non-3 is a constant. Constant times x. That's why when you differentiate x, you just get a constant. Then your dy dx will be y, negative y non-3. Okay, what is the y? Okay, this is a simple function where we can substitute this back, negative 3, negative x non-3. Any questions? No questions? No? Okay, question number 2. Find the equation of tangent. Equation of tangent has been a tangent line. Okay, the tangent line. At a point of 1, 2 to the curve defined by this x squared plus y squared minus x squared minus 3 equals to 0. Okay. Now look at here. Tangent line. What is a tangent line? Let's say you have a curve. You have a curve, and let's say the point 1, 2 is here. Let's say the point 1, 2 is here, and we want to find the tangent line of the curve at this point. It means a tangent line. Okay, so this is the tangent line. The tangent line has the slope same with the slope of the curve at this point. When you want to find on the tangent line, because this is a line, so we can use y equals to mx plus c. So the slope, so this slope, we can get from the dy dx of the curve. Dy dx of the curve. So your m will be the dy dx of the curve at the point of 1, 2. Let's say once you get your dy dx function, you substitute x by 1, y by 2, then you will get the slope because your slope will be a value. Okay. Once you get the slope, you substitute this point into this x and y, get the value of c. Then you will get the tangent line. Okay. So this is tangent line. For normal line, this is normal line. Normal line is perpendicular to the tangent line. This one I think you learned in secondary school. Secondary school. Okay, this is for empty. Okay. The slope of the tangent line. For the slope of the normal line, it will be negative 1 over this one dy dx with the point. Okay, with the given point. Let's say 1, 2. Okay, because the slope of the tangent line multiplied to the slope of the normal line, you get negative 1, right? Okay. So we have this relation. Okay, we have this relation. When you want to get the slope of the normal line, but the slope of the tangent line will be dy dx at the given point. Okay, at the given point. So this one, we want to find the tangent line at this point. So we have to get the dy dx first. Now you get the dy dx. And then you get the dy dx when x is 1, y is 2. Then find for this. Okay, find for dy dx now. Okay, you have to use the product rule for the xy. Okay, keep the bracket because you have a minus sign here. Minus, keep the bracket, copy, differentiate, copy, differentiate. Okay, this is your M for the tangent line. What is your M for the tangent line? What was that for your attendance? Okay. 2 minus 2, 1, 2, 2 minus 1, you get 0. What do you mean when your slope is 0? Yeah, it's a straight line. We are looking for a line. What kind of line? When the slope is 0. Yes. Straight line. It's a straight line, horizontal line. It's a horizontal line because there is no slope. Okay, no slope. Okay, so still we are using the y equals to mx plus b. But your this one, we want to substitute this one 1, 2 into y is 2, m is 0, x is 1 plus c. Substitute this point into x is 1, y is 2, your n, what you found is 0. So your c is 2. Your c is 2, you put back into this. What again? M is 0, and then plus c, which is 2. So we get a horizontal line that passing through y equals 2. Okay. Any questions?
For x, y, division x plus
This one?
division. Kalau dengan x plus
Which one? Okay. Okay, question number 3 is similar. Okay, question number 3 is similar, but number 3 we want to find for normal line. Okay, normal line. So you need to get the m for normal line, which is -1 over the m for the tangent lines. The m for the tangent line is dy dx. Dy dx given the point. Okay, given the point. So for question number 3, the point is 1, -1. So it's 1, -1. Okay, you have to find for the mt first. Okay, then the slope of the normal line will be -1 over what you found here. Then use the same process to get the y equals to mx plus c. Okay, so question number 3, find for the dy dx first. X over y plus 4x equals to 3. Okay, this is normal line and 1, -1. So this x over y, you have to use the quotient rule. Quotient rule. X plus x y. Okay, this one you can either use quotient rule. If you remain in this, you use quotient rule. If you bring it up, you can use product rule. If you multiply all terms with y, you use implicit. Okay, it depends on what you want, how you want to solve it. Okay, quotient rule, product rule, multiply y with to all of the terms, use implicit rule. Okay, implicit differentiation. Okay, you will get the same answer. Here's the answer. Okay, I show you the one with quotient rule. Okay, if you use quotient rule, b u prime minus u b prime over b squared plus 4 equals to 0. Okay, if you use quotient rule, y minus x b y dx will be negative 4y squared. Okay, so x by dx will be y plus 4y squared. Okay, then you can get your d by dx. Y plus 4y squared over x. Okay, so your mt will be this one. By dx, where x y is 1 negative 1. Okay. So when your y is negative 1, X is 1.
Yeah.
So you get a 3. So you get a 3.
But
Okay, so your n for normal line n for normal line will be negative 1 over. Negative 1 over 3. Then y equals to mx plus c. Okay. And your y is negative 1, n is negative 1 over 3, x is 1. Find for the c. Okay, so your c is negative 1 plus 1 over 3. Okay, 1 over 3 minus 1. It's negative 2 over 3. So y equals to 10 x plus c. Any questions? This one I use quotient rule. You can use product rule by bringing this up x, y, negative 1. Or implicit. Huh? Or you can multiply the y to this to eliminate the y. So you have x plus 4xy equals to 3y, then you apply the implicit. Okay, there are many ways for you to get a dy dx. Okay, any questions for this one? Okay, now next, number 4. Number 4, what we use to solve number 4? Okay, number 4. What do we use to solve number 4 to get for the dy dx? Okay, this is a parametric function. Parametric function, so we use parametric differentiation. So this one, you should have dyd data. Okay, both are in terms of data. So dyd data over dxd data. Okay, dyd data. So cos, we get a negative sign. So 3, 4, we get a negative 12. Sine 3 data plus 12 cos 4 data over dxd data. Okay, cos we get a negative sign. 6 sine 3 data plus minus 20 cos 4 data. Okay, so for different kind of functions, you have to know how to differentiate the function. Okay, how to get the derivatives. Parametric functions, parametric differentiation. Okay, product function, product rule. Quotient function, quotient rule. The function where we can't express in terms of y in terms of x, we use implicit differentiation. Okay, so different situation, we have different methods to get a dy dx. Okay. Clear up this? Okay, last one. Number 5. Y equals to x squared e3x sine 4x. Okay, how to get the dy dx? How to get the dy dx? We have to twice product rule twice u v. Okay, so your u is this x squared e3x. V is sine 4x. Okay, then u prime will be, what is your u prime? Product rule once again. Okay, your u prime is product rule once again. So copy, differentiate, plus copy, differentiate, get a 3x squared e3x plus 2x e3x. Okay, and then your v prime. Your v prime will be 4 cos 4x. Okay, now back to here. So your dy dx will be copy, differentiate, plus copy, differentiate 6. Let's read this one. Okay, so you have x squared e 3x 4. 4x squared e 3x plus 4x plus 3x squared e 3x sine 4x plus 2x e 3x sine 4x. You can either, factorize. Okay, you can factorize the x e 3x. Okay, you can factorize the x e 3x. Okay, when you factorize, you get this. Okay, the 1 even in the spike. Okay, any questions? Okay, any more questions? Differentiation is important, very important. So make sure your basic for differentiation is strong enough for you to deal with the EM2 and also your engineering subjects. Because normally lecturer from the engineering subject, they recommend students basic for the differentiation and integration is very important. That's why they have to follow the class, okay, because of the differentiation and integration. So make sure your differentiation and integration skills are strong enough. Okay, enough for you to survive. EM2, I tell you, EM2 is totally different from EM1. The level is totally different from EM1. You know by the time. Okay, so we end our class here. And I will see you next Tuesday. Okay, not class on this Thursday, yeah?
Okay, thank you very much.
Yeah.